We have an equation in X with absolute value expressions and two constants a and b. Question: for what values of a and b, the equation has infinitely many solutions for X. Here's my plan. First, I'm going to give a similar but a simpler example to explain why some equations of this form have infinitely many solutions. Secondly, I'm going to discuss the left-hand side of the equation as a function. Such functions can be expressed as a piecewise linear function, which is the key to the solutions. And finally, I'm going to solve the problem and check the solutions in graphs. Example: equation absolute value of x minus 1 plus absolute value of x minus 2 equals 1 has infinitely many solutions. All real numbers for x between 1 and 2 are the solutions of the equation. We can check a few numbers. First, when x equals 1, plug it in, the equality holds. Secondly, plug in x equals 2, absolute value of 2 minus 1 plus absolute value of 2 minus 2 also equals 1. And we can plug in an arbitrary number between 1 and 2. For example, x equals 1.23. Equality still hold. As a matter of fact, for an arbitrary number between 1 and 2, x minus 1 is positive. Therefore, its absolute value is x minus 1. X minus 2 is negative. Therefore, the absolute value of x minus 2 is 2 minus x. And then we sum up the two absolute values. We got x minus 1 plus 2 minus x. X cancel out. We end up with a constant 1. We can see this from a different perspective. For real numbers s and t, absolute value of s minus t on number line is the distance between s and t. Now, let x is a real number between 1 and 2. Put all these three numbers 1, x, and 2 on the number line. Then, absolute value of x minus 1 is the distance between 1 and x. And the absolute value of x minus 2 is the distance between x and 2. The total distance is the sum of two absolute values, which is the distance between 1 and 2, which is 1. The left-hand side of the equation can be expressed as piecewise linear function. Let's look at this simple example again. The left-hand side is a function f of x equals absolute value of x minus 1 plus absolute value of x minus 2. There are two turning points, x equals 1 and 2. So, these two turning points separated the function into three pieces. First, when x is less than 1, in this case, x minus 1 and x minus 2 are both negative, so the absolute values of them would be 1 minus x and 2 minus x, sum up to 3 minus 2x. And when x between 1 and 2, we already seen this, it is constant 1. When x is greater than 2, both x minus 1 and x minus 2 are positive. The absolute value of them sum up to 2x minus 3. So f of x is a piecewise linear function, three pieces. and its graph is like this. And we can see that between 1 and 2, it is indeed a constant. In this case, f of x equals 1 has infinitely many solutions for all x between 1 and 2. We are ready to solve the original problem, but let me present the results first. We want to find constant a and b so that the target equation has infinitely many solutions. There are a total of 4 pairs of a and b satisfying these conditions. The first pair, a equals negative 3 and b equals negative 4. Plugging them in, we have the equation absolute value of x minus 1 plus 2 times absolute value of x minus 2 plus a, which is negative 3 times absolute value of x minus 3 equals b, which is negative 4. This equation has infinitely many solutions. Why? Let's look at the graph. Of the left-hand side, it's like this, a total of 1, 2, 3, 4, 4 pieces. So when the right-hand side equals negative 4, that's the highlight pieces, and the solution of the equation would be all real numbers of x less than or equal to 1. The second pair of A and B is A still negative 3, but B is positive 4. The left-hand side is the same, the right-hand side is positive 4. In this case, the left-hand side has a graph exactly the same, but if the right-hand side is 4, the solution of the equation would be all real numbers of x greater than or equal to 3. The third pair is a equals negative 1, b equals 0. And the equation is x minus 1 in absolute value plus 2 times absolute value of x minus 2 negative absolute value of x minus 3 equals 0. The graph of the left-hand side is like this, and there's a small constant piece for x between 1 and 2, and the function's value is 0. That is the right-hand side. So the solution of the equation is all x between 1 and 2. And then the last pair is a equals 3, b equals 4. And the equation is like this. The graph of the left-hand side is like this. And the solution for the equation is all values for x between 2 and 3. Now let's see how can we find the pairs of a and b. First, we define function f of x to be the left-hand side of the equation. We need to express the function in terms of piecewise linear functions. First, when x is less than 1, in this case, x minus 1, x minus 2, and x minus 3 are all negative. So their absolute values would be 1 minus x, 2 minus x, and 3 minus x respectively. Sum up according to x, we have negative 3 plus a times x plus the recipes 5 plus 3a. The second case, when x between 1 and 2, x minus 1 is positive, and x minus 2 and x minus 3 are negative. Therefore, their absolute values should be x minus 1, 2 minus x, and 3 minus x respectively. Combining like terms, we got negative of 1 minus a times x plus 3 plus 3a. Using the similar techniques, we got another two pieces for x between 2 and 3 and for x is greater than 3. Put everything together, we have f of x, a piecewise linear function with four pieces. For x less than 1, between 1 and 2, between 2 and 3, and for x is greater than 3. In order for the original equation to have infinitely many solutions, we need at least one of the pieces to be constant. How come a linear function to be constant? Here's the key. A linear function is constant if the coefficient of x is 0. For example, for the first piece, the linear function its coefficient is negative 3 plus a. If this is 0, then the first piece is constant. In this case, we require a to be negative 3. Plug in a equals negative 3 to the expression, we got the value for b. b equals 0 times x plus 5 plus 3a. In this case, a is negative 3, so b equals negative 4. That's how we got the first pair of a and b, negative 3 and negative 4. Similarly, if we assign the coefficient of x in the second piece, negative of 1 plus a, to be 0, we got another pair of a and b, a equals negative 1, b equals 0. And similarly, for the third cases, a equals 3, b equals 4, and the last piece, a equals negative 3, b equals positive 4. That's all I have. Thank you for watching.